Right, welcome back, folks. This time around, we want to tackle about 10 problems which relate to problem solving and algorithm design. So the first question that we have here is we're interested in defining the term algorithm. So algorithm, this is a step-by-step set of instructions that are used to solve a problem or carry out a task. So this is a step way of solving a problem. That's an algorithm. And then we're interested in four stages of solving a problem. So the first one, obviously, is analysis. That will sum them. Analysis, you want to try and make sense of the problem to say what exactly is to be done in order for you to reach the solution. And now, in the process of thinking of a solution, you're going to be interested in the design stage. You design to say, but as I'm approaching my goal, these are the steps or directions that I can follow. The next is to write an algorithm itself. Write an algorithm. From writing the algorithm, I think the last part will be to verify if it's meeting the expected requirements. So this is test and refine the solution. Test and refine solution. So in other words, whatever you thought would be the best way of solving the problem, on the testing, you are checking using either extreme values to say, does the solution cater for all possibilities? Then next, we are interested in stating what is meant by decomposition. So when we say we are decomposing, it simply means we are breaking a problem into smaller, manageable sub-problems, which can lead us to the solution easily. So this is breaking down a break down a problem into smaller, manageable pieces. So in this approach, you'll be able to, from the smaller pieces or sub-problems, then you draw solutions. And after finding solutions from all those parts, then you can easily build or regroup to the major or bigger solution to the entire problem. Then identify the input and outputs in a problem that calculates area of a rectangle. So for inputs is going to be the dimensions that you want, which is length and breadth. These are the dimensions of the shape. Then the output obviously is going to be the calculated area itself. Then next we are interested in writing an algorithm to input a name and then display the name. So here we could properly indicate that these are the input variables that we need in the algorithm, and this is the output or the results of the algorithm. So write an algorithm to input a name and display it. So here we can start the process and input variable name and then output name. Then we stop the process. I'm sure this is the basic algorithm that we would need for uh, receiving a name and displaying it. Now, next we want to write a pseudocode to input a number and output is double. So we can, as usual, start with starting the process. Then we input and the variable is a number. Then we can then say a new variable double is equal to twice the number. Then output, which is what we display, is double. And once we do this, we can then stop. I'm sure we'll be done with that particular algorithm. Name the flowchart symbols used for decision. Now, if you are making a decision, we need a diamond. Well, for input or output, we said we need a parallelogram. That's the one that we use to input data values into the program or in the algorithm. So write a pseudocode that checks if the number is positive. So here we can start the process, and what we'll do is input as we read the number. Then we'll make a comparison that if number is bigger than 0, then we can output that this is positive. So we can output or display positive, positive. Then we end our if, then we stop or end the program. I think basically that's what we have on an algorithm that is designed to, that was determining whether a value is positive. Then next we are interested in stating an advantage of using a pseudocode. Now, when we are using a pseudocode, because it's similar to English or day-to-day grammar that we used to talk, so we can say an advantage is this one, it's easy to read and understand. So we can say it's easy to understand. It's not made up of core instructions of programming languages such that any computer user or any ordinary person can read and follow the sense of what's being desired to be achieved. Then the other one is, which is a benefit, it is not program dependent. In other words, you don't need to know any syntax of a language in order for you to read through a pseudocode. These are just basic step-by-step instructions towards the goal. Now, state one difference between pseudocode and flowcharts. Well, pseudocode uses written steps, and flowchart it uses diagrammatic symbols. So pseudocode, I can say pseudocode uses step-by-step instructions, whereas the flowchart uses diagrams or symbols, which shows the flow and execution of data within a program. I think basically that was it from the first part and algorithms and problem solving. I hope you guys, you found it interesting. We are going to meet again in two supplementary, that's the second supplementary set of questions to check if we can cement our understanding of the concepts discussed. Thank you, folks. Let's meet in the next.